If you hang out with the ORM people, right, they're all like, they hate SQL. They're like, these are real quotes. The image is AI, but they're real quotes. And if you go to the SQL, where the SQL, the database people hang out, they're all this is very slow. They're all anti-ORMs. There's this friction between us all, which is really sad. They're AI images, but those quotes are real. Now, as you can probably tell by the shirt, I'm on the SQL side of things, but I hate this animosity. And funny enough, the guy that even invented Hibernate said that that's not how it's meant to be. We're meant to have a nice relationship between the two. So this session is not about religion. It's not about, I'm going to tell you SQL's the best and ORMs are terrible, or vice versa. I'm trying to get us back together again so we can have a nice place to live. And don't get me wrong, if you've got lots of relational tables, but you want to present them via this kind of schedule, right, as entities on screen, which map to your objects in Java, then ORM is all the way. Go with the ORM, right? I'm not trying to tell you not to use ORMs, but you should also be advantaged to take power, to be able to exploit the power of SQL. If you go to an airline booking site, these are the kind of things that map to your entities in code. Each one of those is a flight. But there's lots of other stuff that often sits around modern web pages or apps. Things like summations, group bys, all this kind of aggregation data. SQL can be used for that as well. So the two can work hand by hand. But don't get me wrong, it's not about SQL everything. I don't want this to be one of those talks where I show you something like that. There's the second page of it. What does it do? It solves Sudoku. Passing a Sudoku board gives you the answer. But let's face it, the percentage of you that need to solve Sudoku as part of your day-to-day job is pretty small. We need to get real stuff done, so I want to talk about real stuff. And the way I'm going to do that is to bring SQL to my typical weekend. My typical weekend is driving my children around to places. I have no spare time of my own. So I'll start with my first son. He plays social basketball. And when you play social basketball, this is the only data you get. At the end of the game, that's who won. I don't like that. I'm a data guy. So I wrote myself a little app that captures every single time one of the players scores a point. Timestamp the game, what quarter it was, who it was, etc. Just so that the kids could have some more data. And then you start getting questions from the coach. Things like, I need the points per player, plus the quarter by quarter totals, plus the grand total. Now in SQL terms, especially if I'm using, say, an ORM which does simple SQL, I might do, there's my quarter and player totals, there's my quarter totals, and there's my grand total. That's a bad idea. That's running 3 separate trips to the database to get the information I needed. And people say, well, that's all too hard. What I'll do is I'll just do it in the app. I'll just drag the data down and the app can do that for me. And then you end up with this kind of problem. You start running out of memory because you're doing a lot of work on data that you dragged away from the database. SQL can do this for us. I can use what's called a roll-up. So this is one trip to the database, one SQL command. It gives me the quarter and player totals. It also gives me the quarter totals, and it also gives me the grand totals at the end. That can all come back to you, and then you can push it into your applications as required. All aggregations are possible. You don't just have to do roll-ups. You can do, for example, cubes. A cube is all the permutations. That will give me, if I do a cube by quarter and player, I get totals by the quarter and player. I get totals by the player and totals by the quarter and a grand total at the end. I get all the permutations of aggregation if I want to. If that's too many, I can actually customize it for my exact needs. I can use a thing called grouping sets. Grouping set says I want to group by the player. Gives me the player by player totals. I want to group by the quarter. That gives me the quarter totals. And I want to group by nothing, which gives me the grand total. So I can choose exactly what aggregations I want, all passing over to the database, run one SQL, get all the data I need nice and quickly. This is really cool, as I said, for these kind of applications. I've got my ORM pulling back all the entities I need, but at the same time, I might want to pull things like all these faceted search kind of things that we have in modern websites. These are all the totals by job, all the totals by salary, etc. All this kind of stuff can be done using some of the SQL tools we've just seen. The problem is when you start showing parents that you're collecting data on their children at basketball, they get all excited. You start getting emails from Susie parent, I saw the report you gave to the coach from the game. It'd be cool if we could get that detail broken down by each player. Now, whenever a parent says each player, they really mean their kid, but that's okay. So we want to help these parents out. So if I start with, let's get some summary data by the team for each quarter. That's pretty easy. There's the quarter, group by quarter. That's very simple SQL. But sometimes my team doesn't do that well? What if they don't score any points in quarter number 3? I still want to print out 4 quarters worth of data because that's how applications work on screen. The problem is data in databases is sparse. We don't store data for things we don't have. And so this is the typical thing we do. We start with just our 3 quarters here and we inflate the data using some other source. So this is Oracle syntax. If it was Postgres, I'd use a generate series. Doesn't really matter. I'm using something to get 4 quarters there so I can then merge it to this one to give me the right answer. So I just use an outer join for that, as I'm sure you're aware. Simply an outer join from the 3 quarters to the 4 quarters, and I get all 4 quarters, including the missing one. That's trivial. But then what if we want it by the player? Well, that's a bit more difficult, because if I have the player here and I want to do the join to the same thing, well, it didn't work. Even though I joined to 4 quarters here, for Matt, I only got 3 rows, and for Max, my son, I only got 3 rows as well. And the reason it didn't work is I actually needed one of these sets of 4 quarters for every single distinct player. And the problem is, at any given time, how many players do we have in the team? Might have 7 one week, might have 8. We don't know. This is a hard thing to do. And what do? We often just go, it's all too hard. I'll drag it over to my app and do the work myself manually. That's slow and it's time consuming. But we have a thing called a partition data join, which simply is you add this one line. Partition these 4 quarters into each distinct player. And suddenly I get 4 quarters for Campbell, 4 for Matt, 4 for Max. The problem solved. Once again, single trip over the database. Database engine did the work for us. I just pull the data back and throw it on the screen. Makes my life easy. These are the kind of things that these are very useful for when you start doing apps on screen, which are, for example, have group bys or effectively control breaks by each individual player. You want to always see 4 quarters, even if that player only played 1 quarter or 2 quarters, etc. Then Mary sends me an email, Mary the coach. She says, we've got a new boy who's looking at joining the team. I don't know much about him, but let's say he gets 13 points per game. Where would that place him? Where would he rate amongst our players? And this is once again one of those challenges because this isn't stored anywhere. You know, this is a kid that hasn't ever played for us. We just know, we think he's going to get 13 points per game, but it's not in any database table anywhere. It's data that's being presented to us. But even with that, we can use some power in SQL to help us out here. We have a thing called hypothetical analytics. It looks like this. If this new person gets 13 points per game, where would they rank based on the points per player descending? So take the players, sum up their points, put the highest number of points first, and then work your way down. If that was the case, he would be the 4th best player. So even though I don't have that data in the table, I can use data in the table with some hypothetical analytics to actually give me where they would rate or where that particular data point rates in my existing data. Once again, I don't have to drag data back and do it in code. The SQL engine can do it for me. And people say, well, let me clarify this. If there's only 7 players, I could just list out the 7 sets of points and just look at it, couldn't I? I mean, I don't really need to write a query like this to work out where 13 sits amongst 7 rows. I just count down, oh yeah, he's 4th. But then what if it's a bit more complicated? What if he averages 4 points per quarter and I want that breakdown on a quarter by quarter basis? Well, it's trivial. I just add a group by in. So now, where does 4 points rank within the points descending, so best points at the top, down to the lowest, but not just by quarter, but by quarter and player, and I get, they would rank, he'd be the 2nd best player in quarter 1, he'd be the 3rd best player in quarter 2, and so forth. Very easy to extend that opportunity. So that's my Saturday pretty much done, right? I drive my son around. The moment I get him home from basketball, my second son says, I need to go to athletics. So I throw him in the car. This is a bit of parental pride here. He's the #1 ranked junior jumper in Australia for long jump. Anyway, once again, I collect data on all these kids. And so here's the long jumpers. And every time they have a competition, they get 4 jumps per competition. And this is the distance. And there's my son, Aiden. And we record all their jumps in meters and centimeters. And I also record what the wind was like, because running into a headwind is hard to do jumps. Running with a tailwind is great. And sometimes there's no wind. And someone says to me, look, I need to find the highest jump achieved by each competitor. And the highest is an aggregation, and that's very easy to do. For each competitor, find the highest jump they've ever done. It's just a group by, and there they have my son 716, Alex 679, and so forth. That's trivial. And this is one of my frustrations with the SQL engine. That's trivial, and then someone says, let's just make a tiny change. With that data, what was the wind like when they did that jump? So when Aidan jumped 716, when David jumped 603, what was the wind like when they did that jump? And I go, okay, that was my original query. I just need to add the wind in, right? So add the wind in, and what happens? You get an error. It doesn't work. SQL can be sometimes non-intuitive, which is a pain. But we have some extensions to SQL. We can use that. We can call the keep clause. This reads a bit weird, I must admit. The keep clause lets you sort by one value, but output another. Normally, if I do a max of salary, or the minimum of a date, the thing I'm doing the min or max on is the result I get back. This lets me say, for the maximum of, say, salary, return me some other value that associated with that row. So in this case, I'm saying, bear with me, it reads a bit weird. Go get the distances, sort them by order descending. So I get the highest distance for each person jumping, and rank them and pick the first one. So if I order them in distance descending and pick the first one, that's the highest one. Once I've found that distance, don't give me the distance back, give me the wind. And it says, when Aidan jumped 716, there was no wind. When Ben jumped 619, there was a headwind, and so forth. So it's cool. Now, you can see the SQLs I'm presenting are slowly getting a little bit more complicated. And as requirements get more complex, SQL gets more complex. And often as developers, we go, that's where I'm starting to draw the line. I don't want to get too much into the weeds. And so here's another question that's come in from my long jump team. Find the average distance jumped by each boy, then with the median of those results, list those boys, those jumpers who got above the median. Suddenly it's a little bit more complicated now. And turning that into SQL is a challenge. But as developers, we are often, we're a machine that turns sentences into SQL. And it's hard. But this is one of the things that I would recommend to any developer, which is a thing called common table expressions, or you might know it as the with clause. Because it's a great mental model for developers. Relational can be daunting. It's all based in abstract algebra. It was invented by this guy. And when I read this is from COD's database paper back in 1970. Data is represented as mathematical any relation being the subset of a Cartesian product of n domains. When I first saw that, I thought, oh, of course. I have no idea what that means. It's like, for me, a database was Excel but bigger, rows and columns, etc. So relational is hard to get your head around. But the with clause lets you take a programmer's approach. You take a task-oriented approach, bit by bit, and get a relational solution anyway. So we do it step by step. What was the first sentence? Find the average distance by each boy. I know how to write a query for that. That's get the name, average distance. And I'll call that the jump average. And then I've tackled just that part of the problem. Then get the median of those results. Well, I know how to write that query. It's just get the median of the jump average, that thing I just worked out before. And then the third sentence was list those players or jumpers above the median. Well, I've got the jump average, I've got a list of the players. I can simply bring those two results together where the average jump was bigger than the median. I never had to tackle the whole problem. I could do it in bite-wise pieces, which is how we generally work as developers. And there's the final query. But I didn't have to think about it as one thing. And rest assured, the database won't run it like that. It'll actually fold all this into one giant SQL and just work it out. But it's good because I didn't have to do that. The database had to do that. That's what I like it. I'm a lazy guy. But yeah, we took a programmer's approach, break a big problem into small chunks, and we still got a relational solution. I love the with clause. It's very cool. It's also great for code reuse. For example, go back 10 years, 20 years, 30 years when I was still writing code. Every application wanted data back in rows and columns. That's pretty much how it came back. Nowadays, in the world of JavaScript and Node and stuff like that, often we want data coming back from the database as JSON. It's the easiest way to map it into, say, JavaScript objects. So if I've got my partition data join example, that was a query we've seen back 50 slides ago. That returns me rows and columns, and someone says, no, we're rewriting this application in JavaScript. I need it back as JSON. Rather than have to rewrite that SQL, I can use a with clause. Here's the raw data as it was from my application 10 years ago, and take those rows and columns and return to me as JSON. And the result comes now back as a JSON array as opposed to rows and columns. So when it comes to modernizing old applications, you can just wrap these with statements in there and get JSON back. Life's good. Long jump's done. Basketball's done. Bit of me time. Finally, a bit of me time. I like to swim laps in the pool. Now, I'm a terrible swimmer. I'm very buoyant, but other than that, I'm a terrible swimmer. So it takes me about 60 seconds to do a 50-meter lap. And for me, my aim is to always be on 60 seconds. I'm trying to minimize all this variability. If I can do every lap bang on 60, that means I'm doing the right amount of exercise. If I go too fast, I know I'm going to blow up. I'm not going to get the laps done. If I go too slow, then I'm not improving my fitness. So I measure. I'm a data guy. I measure these laps. So on this particular workout, the lap was 58.7. I actually went a bit fast. This one was a bit slow, etc. On average, I was pretty close to 60. But really, I'm interested in seeing, am I like this or am I like this? Right? So how often am I sitting around 60 seconds? I'm looking at that variability. So to look at this, I'm going to add effectively an extra bit of information here, which is how far off 60 seconds I was. This one was a bit too fast. It was minus 1.3 seconds too quick. This one was a bit slow. But across these four, I'm pretty happy because these four averaged out to a delta of 0, which means that across the four of them, I had a 60-second average. So it's great to get 60-second average for the whole lot. An ideal would be 60 seconds for every single lap, but this is sort of somewhere in between. I want to measure that. So 60 there, and if you didn't see it, there's another 60 down there, for example. So that I'm trying to find those. Now, because we're using this delta here, and it's not in the database, I'll add it as a column. So I can actually reference that delta column so we don't have to calculate it every single time. And now we can actually have a look. I can actually sum up these deltas as we go by lap. So for the first lap, I was 1.3 seconds too quick, and there's my running total. For the second, that's a bad lap. I ran too fast. This one, I was also a bit too quick. So my running total has now even gone worse. That's another bad lap. Here, I was actually a little bit over. I'm slowly coming back now to where I want to be because this should add up to 0, which means I've averaged 60. That's still a bad lap though. These laps are still bad because the running total has not got to 0. The fourth lap was 1.3 seconds over, which gave me a delta of 1.3, which gave me a running total of 0. That's good. So yes, I'd prefer 0 for every single lap, but these four at least got me back on track. 3 bad ones, I got back on track and I ended up at 0. That's what I'm interested in. And then we continue on through the laps. So it's sort of like a pattern. Now, we're developers, we use regular expressions. If it was a regex, you would say an arbitrary number of bad laps, hopefully none, followed by a 0, that running total coming to 0. Now, I know when I say regular expression, there's an old saying, which is if you have a problem, you can use a regular expression. Now you have 2 problems. But let's go with this. We'll use a regular expression. What's the definition? Well, 0 is when the sum of the deltas, the running total of deltas, came to 0. A bad lap is pretty much anything. Really, it's that 0 I'm interested in. Now, having done all this, can I do it actually in SQL? Well, you can. Literally, this is the pattern. Any number of bad laps that eventually added up to 0. The definition of 0 is the sum of the running total, the sum of the deltas is 0. A little bit of syntax sugar to make sure it works. And out comes this result. And it tells me I had 1 and 4 were bad laps, 9 and 12 were bad laps. So this kind of heavy-duty analysis, we call it pattern analysis, can be done in the SQL engine. That's pretty cool. Swimming's done. I have teenage boys. Anyone with teenage boys in the audience knows that all you have to do is exercise them and feed them. And boy, do they need some feeding. So I've got to that age now where my back's pretty bad. I've sat at the computer all my life, terrible posture, bad back. So I take my bags, but I don't want to hurt my back when I'm shopping. So when I get the shopping, I want to divide the shopping equally into 4 bags due to the weight. So if these are all the things I'm buying, I'm going to need to make sure that I'm going to spread them all nice and evenly to those 4 bags. In that way, I know that I'm going to basically have 2 bags each side. Life will be good. I can do this. It's a pattern as well. Now, this one you've got to bear with me. I've got 4 bags here. How do I allocate things to bags? Well, we can do it in our own mind. I've got 4 empty bags, right? When do I use a bag? I've got 4 empty bags, matching some unknown rules. When do I use a bag? Well, if a bag's empty, put a piece of shopping in that. Next piece, put it in the second bag. Third piece, third bag. Fourth piece, fourth bag. The 5th one's a challenge. because now I've got something in each bag. Where would I put it? In the bag that's currently lightest. So what do? Use this bag if it's the first item in the bag. If this item I'm about to put in is the first item, I would put it in a bag. That means the bag is empty. If it's not, if the bag weight of 1 is less than 2, 3, and 4, I should put it in bag 1. So forth with bag 2, so forth with bag 3. I throw it into this query, add the syntactic sugar, and I get that as a result. Now that looks a bit cryptic, like where's my bags? Right? But if you look down the bottom, we sort of see these sum total of weights that all look pretty evenly distributed. So we learned about the with clause. I can take that previous query, put it in a with clause, there's my raw data, and then wrap the data up using some simple concatenation, and there's my bags. Those items went in bag 1 for 3.57 kilos, bag 2, and so forth. It's pretty cool. The weekend's over. How am I going for time? Yeah, we might get this one done. I've swum, I've long jumped, I've basketballed, I've fed the boys. The weekend's over. I've been doing all this driving, I've got to fill the car up. Now in Australia, I'm not sure if it's the same here in India, we have certain days where the fuel is cheaper. And that's when I fill up. Generally, it's every Tuesday. That's when we fill up. The prices go up every Wednesday, and we have this weekly cycle. So I try to fill up on a Tuesday, even if the car is not empty. So when I look at my car fuel, on the 1st of August, the car was empty, and I filled the whole thing up. But then on the 9th of August, it was a discount day. So even though I had 20% left in the tank, I still filled it up. It's because I go at these random times. Now, I'm having that typical, midlife crisis thing where you go buy a sports car, and the sports car manual says, by the way, only put good quality fuel in there. And it gave me an actual spreadsheet for how to measure the impurities in the fuel tank. It said, if you fill the car up from 0, the amount of impurities, the amount of dirt will be 5% of the number of litres you put in. The other part was, if there actually is some fuel left in the car, well, it's actually the previous dirt, so this one there, times effectively the number of litres you put in divided by how percent full it was. So like a rolling calculation. If the fuel tank's empty, we can work out the dirt easy. It's 5% of the total litres you put in. But otherwise, we need to take into account the dirt that's already in there and roll that into the next calculation. So you end up with this kind of concept. The dirt was 2.25, that's 5%. But to work out this one, I need to know the previous one. So to work out 2.6, it was actually this 2.25 plus the amount you consumed and then the new litres you put in. It's this recursive thing. We've got to write recursive programs to do this. And if you're like me, when you did recursion at uni, it was the worst unit ever because it just messes with your head. But you can do it in SQL. I've got this thing called a results table. It starts with the first row. The first row, my car's empty, right? The first row on the table, take 5% of the litres. Now, to get the next row, though, I need to refer back to myself. So this results table says, select from the car fuel for the first row. For the next row, go back to the table I'm currently defining. This results table refers to itself. And I'm saying, if I'm on sequence number 2, go look at the results from sequence number 1. If I'm on sequence number 3, go look at the results for sequence number 2. It's a recursive relationship in SQL. And when I do that, I run through the recursion, run the results, and I get my calculation. Exactly as you'd expect. It's pretty cool. Let's wrap it up, because that's some pretty rapid fire SQL stuff, and it gets pretty hairy toward the end. I fully concede that. But the thing I wanted to convince you of is we as a community need to step away from these religious battles. SQL, ORMs, Java, JavaScript, C#, C++. We love just crapping on the other side, right? That serves none of us, right? Because every piece of technology is useful in certain ways. So my view is SQL, I think, and hopefully I've proved it to you in this session, that it can be pretty cool and pretty powerful. And the best part is if all those SQLs that return you the results as you need them to your ORM means less code, because your application says, here's the SQL, give me the results. Oh, they're exactly as I need them. Render them. Job done. And anything that's less code means more robust apps, more scalable apps, and they just run faster, which is cool. And it's never too early to start, right? I know, given that a lot of us we work in the application world, we often don't deal a lot with SQL, but it's never too early to start. For example, this is my son. I got him involved in SQL very early on, right? He's very, very keen reader, very keen reader. He's the one that now plays basketball. So as I said, right, I love talking SQL, love talking tech. So that QR code will get you to, YouTube. I've over 700 YouTube videos on database technology, TikTok, Twitter, etc. That's my Twitter handle. My DMs are always open. So if you ever have questions relating to SQL, just hit me up. I'm always here, happy to help. So thank you so much for your time and enjoy the rest of the day.